Okay, welcome everybody. So today what we're doing is we're doing a question 13E from chapter 18D, I believe. It's one of the exercises that were assigned to you for homework. A student requested that I make a solution key, and so here is a video solution for the problem. This video is optional, only if you weren't able to do the problem and if you'd like to see how it's done. Otherwise, feel free to not watch the video. Okay, so they give you a function f of x equals cosine x minus sine x. They want you to determine the position and nature of stationary points. Okay, so not only do you have to find the stationary points, you have to classify the stationary points. And they want you to do it in this interval. So that's going to be important, the interval from 0 to 2 pi. And then they want you to sketch. Okay, so let's get into it. To find the stationary points, you're going to first have to find the first derivative. And oops, I'm going to use black. And you're going to have to set the first derivative equal to 0. First derivative of cosine, the derivative of cosine is negative sine. And then the derivative of negative sine x will just be negative, and then cosine x. Okay, so that's your derivative. It's pretty straightforward. Not so bad. If you want, you can factor out a negative sign from the derivative if you would like. Although I guess you don't have to. Next thing is we're going to set the derivative equal to 0. We're going to set it equal to 0 to find the stationary points. Here you can divide through both sides of the equation by negative 1. That's okay because negative 1 is a non-zero number. And here you might have gotten stuck because now you have a trigonometric equation, but it's expressed in terms of two trigonometric functions. Always the goal with trigonometric equations is the same, reduce it down to a single trigonometric function. In this particular case, what you can do is you can maybe start by moving the cosine x to the other side and then dividing through by cosine x. And in the beginning, it might seem weird or unnatural to do that, but you'll realize that the function on the left now, sine x divided by cosine x, you can just express that as tan x. And what's on the right is just a number. It's just a constant. Okay, and so now you have your trigonometric equation in terms of a single trigonometric function, and now you can solve. The important thing to remember here, though, is, and I find students always forget this, here you're dividing by cosine x. So dividing by cosine x comes with a condition being cosine x is a non-zero value. Okay, so we have to be a little bit careful here. We need to make sure that the solutions for x are such that the cosine of that x is non-zero. Okay, so let's go ahead and find the solutions. I'm going to make a diagram that you guys are familiar with from trigonometry. Here, the fact that the tan of an angle is -1 means the ratio of the y-coordinate to the x-coordinate is -1. So I'm going to make two possible triangles. One triangle is going to look something like this, and then another triangle that looks like that. Okay, and if you imagine these 2 points lying on the circumference of a circle, the ratio of the y and x coordinates are -1 in both these cases. Okay, so first thing you have to do, I'm just going to zoom in here. First thing you have to do is kind of determine these two angles. These two angles are pi over 4 because this is a 1, 1, root 2 triangle, 1, 1, root 2. So because this is pi over 4 and this is pi over 4, the angle that we're interested in is this angle. This angle is going to be pi take away pi over 4, so 3 pi over 4. And then this angle down here, well, that's going to be 2 pi take away pi over 4. So 2 pi take away 1/4 of a pi, that's 7/4 of a pi. Okay, and so therefore we can conclude, well, x is 3/4 of a pi or 7/4 of a pi. Okay. And so those are my solutions. Now here you just have to be careful. The cosine of 3/4 of a pi and the cosine of 7/4 of a pi are non-zero. So both of these solutions are solutions that we keep in our solution set. Okay, next what we're going to do is we're going to probably find the y-coordinates. Okay, so this is the derivative. We don't really want this. We want the original function. The original function is cosine x minus sine x. Okay, so to find the y-coordinates, what we do is we say when x is 3/4 of a pi, the y value is going to be cosine of 3/4 of a pi minus sine of 3/4 of a pi. I'm just going to double check that this is right because my cosine x minus sine x. Okay. Cosine of 3/4 of a pi is negative root 2 over 2. Sine of 3/4 of a pi is root 2 over 2. And negative a half of root 2 minus another half of root 2, we get negative 1 whole root 2. Okay. Now I know I'm using a lot of trigonometry, and I know that maybe these are concepts that you haven't seen in a while. But oops, why am I doing that? But hopefully that makes sense. The next thing we're going to do is we're going to plug in 7/4 of a pi. So when x is 7/4 of a pi, y is going to be cosine of 7/4 of a pi minus sine of 7/4 of a pi. Okay, cosine of 7/4 of a pi is, that's going to be down here. Let me just mark it in here. The ratio of x to the radius there is going to be root 2 divided by 2. Take away, sine of 7/4 of a pi is going to be negative root 2 over 2. Okay. Careful, the two negatives here are going to make a positive, so on the whole, I believe we're just going to get root 2. Okay, because we're adding half a root 2 to half a root 2. Okay, so now we have our two coordinate pairs, but what we need to do is we need to describe them. So I'm going to write my concluding statement. So my concluding statement is going to be something like, therefore the coordinate pair 3/4 of a pi, comma, negative root 2 is blank. Okay, so we're not sure yet. And then 7/4 of a pi, comma, root 2 is blank. Okay, so what we need to do is not just find the stationary points, but we need to classify them. And the way we're going to classify them is we're going to use a sign diagram. So I'm going to draw a sign diagram. And on your sign diagram, we're going to want to label a couple points. The first thing is probably label x equals 0 and x equals 2 pi. And actually, I'm going to change this a little bit. Let's just start at 0 and end at 2 pi. Because we really don't care about these values. We're only interested in the interval from 0 to 2 pi. And what I'm going to do next is just put the derivative, or at least consider the derivative. Okay. And actually, I'm going to write the derivative up here so I don't forget. It's negative sine x minus cosine x. Now, I see a lot of students make the mistake of like using the incorrect derivative. Like there are a lot of things you could use here when you're making your sign chart. It's easy to make a mistake and maybe use this expression or use this expression. But remember that when you evaluate the derivative, you'd want to be evaluating the derivative. When you make the first derivative chart or the sign chart, you want to be using the derivative and not manipulations after you set the derivative equal to 0. Okay. Okay. So let's plot in some of the points. So halfway will be pi. I'm going to mark in 3/4 of a pi here, and then I'll mark in 7/4 of a pi somewhere here. At 3/4 of a pi and at 7/4 of a pi, the derivative's value is 0. Okay. And the reason I know that is because we those were the solutions from this equation. So here it's going to be 0. Okay, what I'm going to do first is test a value between 0 and 3/4 of a pi. A nice value in between there is half a pi. If I plug in half a pi into here, sine of half a pi is 1, so we get negative 1. Cosine of half a pi is 0, so we get negative 1. So we just get a negative value. Okay, and then what we do is we can plug in a value between 3/4 of a pi and 7/4 of a pi. Pi is a good value. Sine of pi is 0, so this is going to be 0. And then negative cosine of pi. Cosine of pi is negative 1, but then there's a negative sign here, so that's going to be positive. And then similarly, between 7/4 of a pi and 2 pi, there's a special angle. The special angle is 11/6 of a pi. Okay, and I'll let you think about how to plug that in and what to do here, but, oh, there's no space here. But it's going to be a positive value. Okay, so that's going to be positive. Sorry, there's just no space here to write. So what we have is 3/4 of a pi comma negative 2. The derivative is changing from negative to positive. That means the function is going from decreasing to increasing. That means that this must be a local min. And then from here to here, so around x equals 7/4 of a pi, the derivative is changing from, oh, sorry, I'm wrong. I'm totally wrong. This should not be positive. This should be negative. Let me erase that. Oops. I probably should have evaluated Yeah, I should have evaluated that. Okay, so for example, if you do sine of 11/6 of a pi minus cosine of 11/6 of a pi, sine of 11/6 of a pi, so you kind of have to visualize where that is on the circle. That's going to be negative and 1/2 take away, and then cosine of 11/6 of a pi is going to be positive root 3 over 2. So on the whole, I believe this is negative. Okay, sorry, there should be a negative sign there. Yeah, that looks right. Okay, but so this is going to be 1/2 take away root 3 over 2, but root 3 over 2 is going to be larger than 1/2, so this is going to be negative on the whole. You can confirm that with a GDC to double check if you don't want to do that analytically. Okay, sorry about that. So that should be negative. So actually this here, the derivative is changing from positive to negative, so that should be a local max. Okay, I'm going to erase all this, and then what we're going to do is we're going to sketch the curve from 0 to 2 pi. And first thing I'm going to do is maybe plot in our stationary points. So if this is pi, 3/4 of a pi, this is 7/4 of a pi. At 3/4 of a pi, the y value is negative root 2. So I'm actually just going to label the coordinate pair, I think. 3/4 of a pi, comma, negative root 2. And then at 7/4 of a pi, the coordinate that we want is positive root 2. Okay? And then the other thing is that you have to worry about, it might be nice to have the intercepts, like the boundary values at 0 and then at 2 pi maybe as well. So let's go back to our original function. When x is 0, cosine of 0 is 1, sine of 0 is 0, so you just get cosine of 0, which is 1. Just plot that there. And then maybe I'll do it right here. And then we also can do 2 pi. So cosine of 2 pi is 1. And then sine of 2 pi is 0, so we just get 1. Okay, so that's going to be 2 pi comma 1. Okay, function should be decreasing from 0 to 3 pi over 4. So decreasing. Function should be increasing from 3 pi over 4 to 7/4 of a pi. Okay, so something like that, increasing. And then function should be decreasing afterwards. Okay, and that's the sketch. Hopefully this question helped you. And wherever you got stuck, just take a note of where you did, and perhaps even try a problem that's very similar to it. So question number 13, we did 13E just now, but it might be a good idea to do like 13F or 13C if you find you struggle with these kinds of questions. I find trigonometry with calculus is one of the more confusing types of problems. Okay, see you all. Stay safe.